Hey everybody, Mr. Bowman here. Today's learning objective is in yellow. We are learning to determine which edges have the least and greatest impact on our minimum spanning tree. So minimum spanning trees are the key part to this video here, but we're going to be doing a few of them, and this diagram may look familiar, but just to illustrate all the different unique variations of the type of question, I've just added on an extra root, Southampton to X, just for kind of conversational purposes here. So to do this table, or to do this type of question, we need a big table. And what we're going to do, we're going to consider the edge and the weight. And these are the parts currently in our minimum spanning tree. We then need to think of, well, what kind of replacement do I need if that's not possible to construct? And I'll explain that in more detail shortly. And then finally, what's the difference? And I should actually maybe be a bit better. I should write difference/impact on the minimum spanning tree. So before we get into the table part of it, let's have a look at the diagram and let's work out the minimum spanning tree. So we have a polygon here, applying the polygon approach. And I know that 75 Bristol to Southampton, that is not needed for our minimum spanning tree. Same thing over here. Here's another triangle. Here's another polygon. So let's get rid of the 70. Carrying on, there's one more up here. Let's get rid of that 45. And then finally, along here, Oxford to London, that's the longer side there. Don't need those. No other loops, no other way to kind of backtrack along our diagram. So that there would be our minimum spanning tree. So now that we've got the minimum spanning tree sorted, we can start thinking about this idea of impact on our minimum spanning tree. So we're going to look at the first one, I suppose, is over here, Brighton to Swindle. So let's write this in our diagram. So BR to SW. And that had a weight of 40 currently. So let's say for whatever reason, maybe this edge here was not physically possible to construct. How would have I connected Bristol to our the rest of our network? And what that meant, or what that forces, is that 75 that we crossed out earlier, the only way we can get to Bristol is via that pathway. So we're going to need to reinstate that pathway as part of our network. So our replacement edge here would have been, so we're going to go, well, Southampton to Bristol would have needed to be included instead. And that edge weight was 75. We crossed that out before because that was the biggest number. The difference between these two from here to here, so let's say you're doing a budget, how much has your budget increased by putting the 40 up to the 75? And in this case, it's increased by 35 units. Whatever the units might be here, I suspect it's probably going to be like millions or billions of pounds if you're talking about a rail network. So we've considered the first one. Let's now consider the next one here. Let's consider Swindon to Oxford. So Swindon to Oxford. So if this edge here was physically not possible to construct, what that means is this portion of our diagram would have been cut off from the rest of our network. So we need to think, well, what's the easiest way, the cheapest way to connect them now? And if you have a look, it's going to be one of these two pathways over here that we had previously deleted. It could be Reading, which is 45, or Swindon, which is 70. So the 45 pathway would have been the best way to connect it. And what that means is this edge here and these edges here that are disconnected, we're going to connect them via that one that we previously eliminated. So we're going to need to add Swindon to Reading to make up for the Swindon to Oxford not being possible. So we've got Swindon to Reading. So our weight initially, we can't do that 30, so that needs to go away. But we can add in that 45 now instead. And what that means is our budget, it was increased by 15 units. So we've done this edge here now, and we've done this edge here now. The next ones we'll tackle with, let's tackle with all the ones that are already scribbled out, because we can deal with those all at the same time because they've got the same logic. So we'll do the first one together. So Bristol to Southampton. if it was physically impossible to construct this edge, maybe due to engineering reasons, maybe there's a housing development in the way and you can't bowl that over, what would the impact be? And in our case, it would have no impact because that edge wasn't part of our network anyway. So the impact here would have been 0. And the same with Swindon to Southampton. It wasn't part of our minimum spanning tree, therefore it has no impact on the minimum spanning tree. So again, dash, dash, it has 0 impact. Same with Swindon to Reading. So we've got Swindon to Reading. It had 45, and then dash, dash, it had no impact because it wasn't part of our minimum spanning tree. And then finally, let's do the same for Oxford. Oxford to London, 60, and again, dash, dash, 0, no impact on our minimum spanning tree. So we've now dealt with all those ones. Let's think about the other ones. So we've got Oxford to Reading here. Oxford to Reading, it had a weight of 27. So if this part of our network here was physically impossible to construct, what that means is, if you have a look, I'm just highlighting it here, those 3 nodes are now disconnected from these 3. So what would the cheapest or the most efficient way to connect them be? And it's probably going to be that 45 down the middle, and you can see now they're all connected to each other again. So let's get rid of all that. So we're going to replace that with Swindon to Reading. And that had a cost of 45, which means our increase in our budget was 18. So you'll see that Swindon to Reading has come up twice already. And if you think about it, that does make sense because Swindon to Reading, of the ones we had previously eliminated, that was the cheapest of them. So it makes sense. That should be the first thing we should bring back if we need it. And so I wrote 18, but that should be plus 18 there. So let's give that one there a tick. So we've now done that. We've got 3 left. We've got 1, 2, 3 to consider. So let's have a look at the London to Reading leg. So we've got London to Reading. So if that was not possible to construct, what that means is Old London, if you have a look at the rest of our network, Old London is now disconnected from that network. The only way to reconnect it would have been via the Oxford route. So let's add that in. So we're going to need Oxford to London. We're going to need that to be reinstated. So we are losing the 40 because it was impossible to construct the 40, and we have to add back on the 60. So that means it has an impact of plus 20. So let's give this one here a tick. Notice I tick them off just to make sure I'm thorough and I'm not missing any of the obvious ones. We've now got Reading to Southampton. So let's write RE to SO. It has a weight of 42. Who do we need to replace that with? So if this one here is impossible to connect, what that means is our network here, Southampton to X, would be disconnected, if you have a look, disconnected from the rest of the network. So there's no way to connect those. So we need to think, how can we connect this with the rest of our network? And it's going to be one of these other 2 pathways over here. So it'll be one of these 2 ones here. And the 70 route, Swindon to Southampton, would have been the most efficient way to do that. So let's include Swindon to Southampton on our diagram. So we need Swindon to Southampton, and that had an increase of 70. And gosh, that was quite a big impact. That there was an impact of 28, or plus 28, which is the second biggest impact we've had so far. And then finally, so given that tick, we've considered them all now, apart from our red one, that was the addition from the diagram. So let's consider Southampton SO to X. I didn't put a weight there, I just realized. Let's say that there was going to be 30 million pounds, whatever it might be. How could we reconnect it? So let's highlight that. So if this one here is impossible to connect, we've got our network, or the rest of our tree, we've got it over here. And if this was impossible to connect, that means there's no other way to connect X because there's only one way in and out. So that means there are no alternatives here. So we'll write no alternatives. And this one here is a bit annoying because how can we figure out the difference? So when you think about this one here, we need to think a bit outside the box. Well, the nearest two nodes are going to be to London and Reading. So we need to think, well, what would the cost of X to London be? So X to LO I'm writing. And same thing, what would the cost of X to Reading be? That there, or the cost of doing those two there, which we don't have, would probably be the impact on our overall tree. So this one here, a bit messy. What I'm going to do is I'm going to delete our diagram now, and we can start analyzing and interpreting our results. Now, even though this question chats about least and greatest impact, that kind of suggests you're talking about two pathways. There's actually quite a few things, annoyingly, that we need to talk about. The obvious one is going to be the greatest. So that Brighton to Swindon, if that was not possible to construct, it would have the biggest impact. So let's start our conversation there. So if Brighton to Swindon, I'm just going to use some abbreviations here, was not possible to construct, it would have the greatest impact of plus 35. It would have the greatest impact, oh, forgive my bad spelling, of plus 35. I'm being pretty generic. I wrote plus 35. In your real internal, it may pay to include the units and be a bit more specific than I'm doing here. So we've considered the greatest impact. The next thing we want to talk about, because the word least is where it gets a bit annoying here. So these four here have no impact. So is no impact the least amount of impact? Not too sure. So that's why we're going to chat about all four of them. So we're going to say Brighton to Southampton, and then we've got Swindon to Southampton, and then we've got Swindon to Reading, and then we've got Oxford to London. Did not form part of our original spanning tree, did not form part of our, I'll be a bit lazy, all right, MST for minimum spanning tree. Therefore, they had no impact on the overall cost. And that one's a bit annoying. So no impact, I'm not sure if it actually means least. So we're now going to talk about the least impact. And in our case, the least impact is actually going to be that 15, that Swindon to Oxford. That's okay for it not to be possible to construct it because it only cost us 15 instead of 18, 20, 28, 35, whatever it might have been. So Swindon to Oxford. So SW to OX had the smallest impact of plus 15. So we've done that, and then the only thing that's noteworthy is it wasn't actually possible. This last one here, we don't know the impact because we didn't have another option. So the engineers or the people constructing this network, they would have had to gone out and costed or find out how much this would have been if that was possible. And then that's our last point. So we're actually talking about four things, even though we're talking about least and greatest. So we're going to say, annoyingly, there was no alternative if Southampton to X was not possible. To construct. Oh, forgive me as I've gone over there. And this is when you talk about we need more information needed, more info on X to London and X2 reading needed. And that wraps up this question. It was 15 minutes for the excellence part. It was a bit of a mess. And it wasn't just the least and the greatest in the end. We had to talk about the greatest impact. We had to talk about the edges that were never part of our spanning tree in the first place, so they had no impact. We then talked about the smallest impact. And then finally, we talked about something we're not sure about. So that wraps up this type of question. All of those may come up in your real internal, but some of them may not, as forgive me, as well. Thanks so much for watching. Now let's get into heaps of practice.